Hello. Let's get started and do the rest of 6.5, which I called 6.5b, area enclosed between two graphs. All right, so we're going to find the area enclosed between two graphs. Before we found the area between the curve and the x-axis. Now we're going to do between two graphs. So we have the area of f of x equals 2x squared, or the function of f of x equals 2x squared. The g of x equals 2x plus 4. So the first thing, I wrote down some steps. You're going to draw it. So I drew 2x squared is a parabola, so I drew a parabola. And g of x is a line, so I drew the line. I tried to draw it as straight as I can. Number 2, I'm going to shade the area between. So I shaded the area between in green. Then I decided which graph is on top. So which graph is on top is the line. The line, or the g of x, is on top, and the f of x is on the bottom. That will come up in a minute. Before that, we have to set them equal to each other, or we should set them equal to each other to solve for which one is the points that you're going to use. You need to find like your critical points. Before I gave you from x equals 0 to x equals 1/2 or something, I didn't give that to you now, so you have to find their points of intersection for the critical points. So I've set 2x squared equal to 2x plus 4. I subtract 2x, I subtract 4. I get 2x squared minus 2x minus 4 equals 0. I divide out the 2. When I divide out the 2, I got x squared minus x minus 2, and I notice that I can factor that. It's going to be 2. You get factors of 1 and 2. If you do 1 minus 2 or 2 minus 1 to get negative 1 in the middle, it's going to be 1 minus 2. So you have 2 times the quantity of x plus 1 times the quantity of x minus 2. Your critical points then are going to be setting those equal to 0. I have negative 1 and 2. Notice there's no 2x on the outside, so there is no 0 there. So negative 1 and 2 are going to be what's going to be at your top and bottom of your integral. That's going to be your defined points. So this is negative 1 something, and this is 2 something. I really don't care what somethings they are. The y values doesn't make a difference for me. Okay, so now, because you needed to know the top and the bottom, you have to do the subtraction. And you take the term that was the top function, in this case the line, 2x minus 4, plus 4, is going to be first, and you're going to subtract the parabola from that. So I'm going to subtract the parabola from that, and that's what I'm going to integrate. So I integrate 2x squared over 2, integrate 4 is 4x, integrate 2x squared is 2x cubed over 3, from negative 1 to 2, and I start putting in my numbers. 2 squared plus 4 times 2 minus 2 times 2 cubed over 3. In red, I got 4 and 8 and 16 thirds. In a minute, I'm going to find a common denominator, but not right now. Negative 1 in there, negative 1 squared plus 4 times negative 1 minus 2 times negative 1 to the third over 3. And again, I have 1 minus 4 plus 2 thirds. Do some math in there. Outside, if I do all the thirds in the outside, I got 12 plus 24 minus 16, or 20 thirds. On the inside, I have 3 minus 12 plus 2, and I got negative 7. But that negative is with a negative, and the negative of a negative makes that positive. So 20 thirds plus 7 thirds made 27 thirds, or 9 units squared. The area between the two curves. All right? Next one. And we're just going to do a couple problems to make sure you understand where the area is between these curves. So the first one is f of x equals 10x minus x squared. I recognize that as a parabola immediately, and it's a negative, so it's going to be in a downwards parabola. And g of x equals 30 minus x. Again, I'm not so worried about proportionality on my graph as I am what are the x values and what are the y values. So I set them equal to each other. I subtract 10x and plus x squared because I decided I wanted a positive x squared to factor. I get x squared minus 13x plus 30. I see that 30 has a bunch of factors, but to add 30, two of the factors, if I add 3 and 10, I get 13. But I needed a negative 13x, so I get x minus 3 and x minus 10. So 3 and 10 are my two critical numbers, 3 and 10. Then I check to see who's on top of the shaded part, not who's on top in any one left or right side, on top of the shaded area. And on top of the shaded is the black, and the black represented the parabola, so it's the parabola minus the line. That is supposed to be 30 minus 3x. I think my finger got in the way. So I distribute that negative. I get minus 30 plus 3x, and I see that there's terms that I can combine. So I combine them before I integrate. 13x minus x squared minus 30 dx from 3 to 10. I integrate that. I get 13x squared over 2 minus x cubed over 3 minus 30x from 3 to 10. Then I stick those numbers in. 13 times 10 squared over 2 minus 10 cubed over 3 minus 30 times 10. Do the math. I get 1,300 over 2 minus 1,000 over 3 minus 300. I put the 3 in, subtract the quantity of. Remember, that's going to be a quantity. That whole thing, you do find the math inside before you subtract it. So I have 13 times 3 squared over 2 times 3 cubed over 3 minus 30 times 3. I get 117 over 2 minus 27 over 3 minus 90. Yes, you can use your calculator. I do the math there. I take this math minus this math, and notice I did it all in my calculator with parentheses, and I got 343 over 6 units squared. Do I have any questions? All right, let's go to the next problem. Well, how can I make it more difficult? That's my question. Well, what if I have the area of two curves that has more than one regions? That has more than one region. So we're going to find the area between x cubed and x squared plus 2x. And so we have this lovely, x cubed is this pink. I don't know how much you can see because I tried to do the coloring too. So the pink is a curve like this. It starts at negative 2,8 and goes through. And then negative x squared plus 2x is another downwards parabola. Looks like I touched it again. Got a smudge there. And so I have 2 points there. I noticed that when I graphed it, there's this side, the pink is on top of the blue, but over there, the blue is on top of the pink. So I have 2 regions, and I'm going to have 2 different ways that I'm going to integrate that. But in the beginning, I need to find where are my points of intersection. So I set the 2 equal to each other. I like the fact that this is x cubed, so I added x squared and subtracted 2x. I get x cubed plus x squared minus 2x. The first thing I see I can factor out is an x. So I take the x out. I've left the x squared plus x minus 2, the quantity. I decided I can factor that. We did that on an earlier problem. 1 times 2 is 2, but this time it's a subtraction sign. So is it 1 minus 2 or 2 minus 1 to get a positive 1 in the middle? Well, it's 2 minus 1. So it's x plus 2 and x minus 1. But don't forget the x on the outside. When you have an x on the outside and you set all your quantities equal to 0, you'll have 3 critical points, 0, negative 2, and 1. If you put them in order and you see them on your graph, you have a negative 2, 0, and 1. So this integral is going to be from negative 2 to 0, and that integral is going to be from 0 to 1. So I have 2 sets of integrals that I'm going to have to do. The first set, again, you have to check which line or function is on top. This one is the pink. The pink represents a cubic. So the cubic is x cubed minus the parabola, negative x squared plus 2x. I have to distribute that negative before I can even think about integrating. I have x cubed minus x squared minus 2x dx. So I'm starting to integrate that. I have x to the 4th over 4 plus x to the 3rd over 3 minus 2x squared over 2. The 2's nicely cancel from negative 2 to 0. I'm showing all the math this way first. I start with a 0. That's interesting, and that's very specific. So you have all these zeros, 0 to the 4th minus 0 cubed minus 0 squared minus the quantity. That negative is very important. You're going to have to bring that down. If you don't bring it down, you're going to get a negative answer. Negative 2 to the 4th over 4 plus negative 2 to the 3rd over 3 minus negative 2 to the 2nd. If you do good math, you have 16/4 minus 8/3 minus 4 inside the parentheses. The 4 minus 4 cancels. I get negative 8/3, but don't forget I had that negative on the outside, so I get this purple 8/3 answer. But we only did this portion. We see that this portion has a graph. On this portion, the parabola is on top, so the negative x squared plus 2 minus the cubic, x cubed. So we go on that one, and now we integrate it. Negative x cubed over 3 plus 2x squared over 2 minus x to the fourth over 4 from 0 to 1. Why from 0 to 1? Because those are the criticals, or those are the points of intersection on that part of the graph. So here we go with our math. Negative 1 cubed over 3 plus 1 squared minus 1 to the fourth over 4 minus 0. Why did I know it was 0? Because over here I had plugged in all the zeros and it became 0. Be careful with the 0 though, because like e to the 0 will become 1. So make sure you do the math out and check. So I had negative 1/3 plus 1 minus 1/4. I put everything in twelfths. I get 5/12. I noticed that this was 8/3, so I change it to twelfths. I get 32/12 plus 5/12 is 37/12 units squared. How you doing? All right, so where will I ever use this, Mrs. Reed? Oh, with an application. So here we go, and you know that I like my applications, and I also like my maximum revenue and maximum cost and everything. So we're going to do a revenue cost function. And I did not write the entire word problem down. I believe it's on page 458 or 9. It's the last word problem in this section if you're reading the book. The revenue rate is R prime of t equals 9 minus t to the 1/3. And the cost rate is C prime of t is 1 plus 3 to the t, 3t to the 1/3 in millions of dollars. That's important because of your answer in the end. How long will the company operate and what will the profit be? Profit is rate minus or revenue minus cost, so you'll need to know that in a while. But I figured I didn't know where I was going or starting, so I decided to set the two equations equal to each other. And when I did, I added the t to the 1/3 to the side. I got 4t to the 1/3. I subtracted that 1. I got 8. 8 equals 4t to the 1/3. I divided by 4. 2 equals t to the 1/3. I cube both sides and I get 8 equals t. Guess what? That's how many years they're going to be profitable. Okay, if you also look at the graph, the revenue goes down, the cost goes up, the shaded area between is there, and there's your 8. So where do you need to go? Is from 0 to 8 years. So because of profit is revenue minus cost, you do revenue minus the cost function. So you distribute that negative, and after you distribute that negative, I did some quick math here. I did 8 minus 4t to the 1/3. I had some help over here. That's why I put that arrow there. So I realized that if I put that over this side, it would have been 8 minus 4t to the 1/3. I integrate that. I get 8t minus 4 times t to the 4/3 over 4, reciprocate 3, and I cancel the 4's out from 0 to 8. I put my 8 in. I get 8 times 8 minus 3 times 8 to the 4/3 minus the quantity again of 8 times 0 minus 3 times 0 to the 8/3. And you do good math is what you do. 8 times 8 was 64. 3 times 8 to the 4/3. Well, believe that or not, 8 to the 4th is, I don't know, some big number, but cube root it is 16. 16 times 3 is 48. How did I know that? I used my calculator. 64 minus 48 is $16 million in 8 years. Remember, there was 2 questions. How long and how much money? So $16 million in 8 years. Your assignment tonight will be 6.5b. It'll be the rest of the assignment on the syllabus. Page 462, 11, 15, 17, 21, and 24. I'll let you look at that for a minute, and then I'll take it down and turn it off and post it. Hope you're having a great day. Area between two curves.